expression. It's good to take a second look, make sure you didn't miss anything. Example 3. Factors can be just bigger than a variable or number. But first, what's the difference? Well, let's compare 3 factors to 6 terms. Do a little paper magic trick here. We're going to start this way. Let's talk about 3 factors. 3 factors are if I say 3 times fact times ORS, I have multiplication in between here. So I can have big expressions inside, but what you see is that there's a black factor of 3 times this group of letters that are grouped together. And so because there's black multiplication between these groups, it makes 3 factors. No matter what's going on inside of here, the black denotes the separate factors. Where in this case, I have 6 terms. Notice that each letter is isolated as its own entity with plus signs in between. And they could be minus signs too. So, as we did example 1 and 2, you can recall that we had all factors. If I had all terms, it would look like this: 4 plus 6 plus 8x. If I had all 4 plus 6 plus 8x over 2 plus 6x, could I reduce the 2 with the 4? Or the 2 with the 6? Or the 6x and the 8x? No, because they're all plus signs. These are terms that it would be illegal to do. But if we could factor the numerator, if you put this together on top, you have a 10 plus 8x over 2 plus 6x. This is still not something we can simplify at all. But if on the top, if I could pull out a factor, so I end up with 2 times 5 plus 4x divided by 2 times 1 plus 3x. Now I have 2 times this quantity and 2 times this quantity, and the 2's reduce. Therefore, I have been able to simplify all the way down by canceling those 2's to a 5 plus 4x over a 1 plus 3x. These parentheses tie the numerator and denominator terms together. So, sometimes you're going to look at an example like this rational polynomial. It may be partly factored for you, but the key is to keep looking for common factors. You can even kind of cheat by looking at the base, looking at the denominator, and you may see common factors. I have a trinomial, so my expectation is this is going to factor. Ooh, we all like this, x squared minus 9. We know x squared minus 9 will simplify to an x minus 3 and an x plus 3. I know that my factors up here should end up being somewhat identical. The whole point of the lesson is to have some factors cancel. Notice I have multiplication between all of these factors. Up here I had multiplication as well, but nothing was ready to reduce. Inside of the black parentheses, x squared plus 4x plus 3, we all know it's going to factor x plus 3 and x plus 1. Now, looking at the black parentheses, I can simplify 5 times x times this times that. X plus 3 is exactly the same whole factor as this x plus 3. The whole factor reduces. Upon doing that, I end up with a numerator then of 5 times an x plus 1, and I have x minus 6 and x minus 3 in the bottom. But there are some restrictions. What are the restrictions we're looking at? Well, what is the one value you never can have in the denominator? The one value you never can have in the denominator is a 0. There's no such thing as zeroths. This is any number over 0. That's bad. We can't do that. So, what do we want to stick from? What 2 values in this equation would cause there to be a 0 down here? Well, what makes this a 0 and what makes this factor a 0? Well, if you take x minus 6 and put it equal to 0, you get x equals 6. X minus 3 put equal to 0, x equals 3. This factor cannot be a 0. This factor cannot be a 0. So by moving it to the other side, x cannot be 6 and x cannot be a 3. The restrictions are x cannot be a 6, x cannot be a 3. This is our simplified rational expression. These are the restrictions. Last example I have for you is very similar, except the fact that now what we have is a fraction on top of a fraction. If I'm dividing, and it helps if you make this line nice and dark, if I'm dividing by a fraction, I can multiply by its reciprocal. So I've rewritten it as a reciprocal here. When we do that, we want to factor then each piece. We need factors to reduce, so a squared stays the same. A squared plus b squared becomes a plus b, a minus b, and we have b minus a over 4a. Now, what simplifies? Well, an a will fall out, leaving an a on top. What about a minus b and b minus a? Are they the same? Well, they really aren't. They aren't quite the same. They're almost the same. They're different by a factor of -1. A minus b is different than b minus a. 5 minus 3 is a 2. 3 minus 5 is a -2. So if I were to cancel this factor with this one, I'd actually have a remaining factor of -1 left. Then we can just multiply through the top and through the bottom. I end up with a -1a over 4 times the quantity of a plus b. Good luck. Have fun on the assignment. Check out the examples if you're having any trouble.